Hello, friends. Good evening and welcome to Eastern Academy. And today is Embedded System Programming, week 13 and day 2. And so far we were discussing about buses, SPI, I2C, and host bus and other things. And today we will discuss about some memory types. What is called flash, what is not flash, what is non-flash, what is DDR, what is the DRAM, all those things. We will have a top level bird view today, and that will be helpful for you when you are doing in embedded things, because they are nowadays getting used in all the embedded systems. But also you should know, as an electronic student, you should know all these latest technologies. And before we proceed onto the thing, I'll give you a little bit about idea about timing diagram. Timing diagram is not a great. People ask, everybody is wanted to know about timing diagram. So we'll have a small discussion about timing diagram. What is timing diagram? It's nothing. On a wire, something is happening. On a wire, something is happening. You have a switch, and here is that guy is receiving. Understood? And you have one more signal. You call X and Y. Instead of writing in English, Y signal is asserted at 10 nanoseconds after X signal 0.1. Y signal is asserted after X signal is asserted. 2. X signal is kept for 120 nanoseconds. Third, Y signal is kept for 60 nanoseconds. Understood? So I can start writing everything in English, but you know about engineers, they wanted to avoid the thing in English. So what they made was, they made a diagram, time versus voltage. Time versus voltage, the graph. And since I have two signals, X and Y here, then I have one for X. They normally give it on different color. The blue for X, and I have red for Y. Now see that X is, I assert the X signal. See that I assert the X signal. I make the X signal high. I normally, I'll give you a reason why I draw this. I make X. What I have written here is Y signal is asserted 10 nanoseconds after. That means that I make a Y signal after 10 nanoseconds. So the timing. Okay, I don't write here 10 nanoseconds. I call T1. Okay, then you see here, X signal is kept for 120 nanoseconds. Now, this time, that is here to here, I call T2. Okay, then Y signal is kept for 60 nanoseconds. You see here, Y signal is kept for 60 nanoseconds. Then I call this one, this time, T3. In a table, I'll say T1, T2, and T3. Then I have three types. One is called minimum, One is called maximum. One is called, typical. One is called maximum. Typical means most of the time you will get this. One, let's say T1. How much T1 I said? 10 nanosecond. Sometime it may be up to 8 nanoseconds. Sometime it may be 12 nanoseconds. I don't know. It may vary a little bit. Depends on they have measured it that IC behave like that way. Then you say T2. T2 is 120 nanoseconds. They write 120. A typical. Whereas minimum could be 110, maximum could be 130. Then you say signal. A Y signal is kept for 60 nanoseconds. That is T3 Y. That is 60. The maximum could be 75. Minimum could be 55. This is what you will see that. That is, every timing diagram, they will draw like this. They will put T1, T2, T3, everything. The data, the name will be changing. And that will be pulled on the table. Let us take a small thing about microprocessor. And also you have to understand a few things. In timing diagrams, one most important thing is this. It goes from high to low. But we don't draw like this because this is not possible. At a given point of time, T is equal to T1. The voltage on a wire cannot be 0 volt and 5 volt. It can be 0 volt or 5 volt. Please understand. It cannot have two voltages same time. That's the reason we draw like this. So there's a small gap. That gap is very important. That depends on the wire length. Okay, that depends on the what do you call speed of the clock. All those things. For example, let us assume that if a clock, let us assume that the clock is 1 megahertz. If we say the clock is 1 megahertz, if it is 1 megahertz, then the clock width is 1 microsecond. Am I right? 1 microsecond. Because 1 by 1 megahertz is. But I'm pretty much sure that we don't give serious importance to that. These are all, I told you that if you want to be successful in embedded, you have to give all these things by heart. 1 by 1 megahertz, 1 by 1 kilohertz, 1 by 1 gigahertz, 1 by, that's all, not more than that. 1 by, 1 millisecond, 1 microsecond, 1 millisecond, 1 giga, this one, nanosecond, 1 picosecond. If I tell you that 50 picoseconds, how fast you can write that? How many frequency it is? What is the frequency? It's a T. T1 is 50 picoseconds. What is F? That's a trick. If you could write up 20 gigahertz, then you are great. How fast? That the timing is very important. If we say 50 picoseconds, yeah, exactly. You are right. That is what. They are the problem. The wire itself is the problem. Wire, noise, so many things. These are all full. Everything is electrical. Everything is electrical. Please understand. Nothing is electrical. These are all electrical. So, I am telling you now, I am having a clock of 1 megahertz. Now, the 1 megahertz, this time is 1 minute. Due to the wire, if the rising time is 1 nanoseconds. Think that 1 nanosecond. This is 1 microsecond. That means how much? This is 1000 nanoseconds. And 1000 nanoseconds, 1 nanosecond is maybe too small. Am I right? It is too small. Suppose I am having a clock of 100 megahertz. How much? 100 megahertz. Then this time becomes 10 nanoseconds. when it is 100 megahertz, that time you will see that 1 nanosecond is big. Suppose I am having 200 megahertz, then this is 5 nanoseconds. In 5 nanoseconds, the time is still big, 1 nanosecond. This is all small graph. Now I'm telling you that why sometimes they draw like this, sometimes they draw like this, sometimes they draw like this. Because the rising time is 1 nanoseconds, but the total time is like this 5 times. And this is also 1 nanosecond, and this is 1 nanosecond. This is 3 nanoseconds. Understand? Totally 5 nanoseconds. So when I have a 200 megahertz clock, now the 1 nanosecond is too big. That's why we put a slant like this. Let us say I have a 100 megahertz clock. Then this duration is 10 nanoseconds. So this is small, 1 nanosecond. This is 8 nanosecond. And this is 1 nanosecond. Now the slanting is too small compared to this. This one, I am 1 megahertz. So this is 1000 nanoseconds. So the 1 nanosecond is too small. The remaining one is 998 and 1 is here. That's why sometime the waveform, you will see like a square. Sometime you will see a trapezoidum of a very slight deviation. Sometimes you see a trapezoidum of too big. That depends on the rise time of the clock due to the frequency. That you have to understand. Okay. So the thing is this, what I'm trying to say is that what you will see in timing diagram. In timing diagram, you will see first low. This is low. That is 0 volt. Second, high. 5 volt. That is fine. Third thing is low to high. Fourth one is high to low. These are 4 you will see. But what you don't understand is the 5th one. That's a confusion. The 5th one, they will write like this. Understand? There will be a blank. And they also write a number here. 3063 6B. 306B they write. You may not understand what is this. Nothing. Now I have 2 signals. A0, A1, A2, A3. A1 is 0. A2 is 1. A3 is 1. A4 is 0. Okay. 0, 1, 1, 0. Now, if we combine all of the 4, you don't know whether what is what, because one is high, one is low. That's why we draw like this. Here I write 0, 1, 1, 0. 0, 1, 1, 0. This is A3. This is A2. They write here A. A0 to A3. This is called bus. When we draw bus, we draw like that. If I have a 8 wires, A0 to A7, I write here 7, 8. That means that 0, 1, 1, 1, 1, 0, 0, 0. A0 to A7. If I write 16 wires, I write here 7, 8, 4B. 7 means 0, 1, 1, 1. 8 means 1, 0, 0, 0. 4 means 0, 1, 0, 0. B means 1, 0, 1, 1. If you say 32 wires, then I write like this. 1, 7, 6, 4, 3, A, C, E. It's so big. See that? Instead of drawing like this, A0, A1 up to 31 lines, instead of drawing 31 wires, I draw one line. This is 0, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 0, 0, 1, 0, 0, 0, 0, 1, 1. A means 1, 0, 1, 0. C is 1, 1, 0, 0. E is 1, 1, 1, 0. A0, A31. This is what's happening. You understand? This is what is represented here by this. You know what is this? This is called X. Don't care. You know what is this? This is called tri-state. If it is on if it is not neither 0 nor 1, this is 0, this is 1. This is neither 0 nor 1. This is called tri-state. That means that nobody is driving the bus. Okay. So there are 5 in timing diagram. Remember, there are 5. Okay, one is low. Second one is high. Third one is low to high. Fourth one is high to low. And fifth one is bus. Bus can be any size. Bus can be any size. It could be of 1 or 4 or anything. 8, sorry, 2, 4, 8, 16, 32, 64, anything. But we draw it on only one set of wires. Now, let us think about microprocessor. Let us take a microprocessor. The microprocessor is giving a clock. Let us say this is a clock. Okay, now let me draw the clock first. Now, what this microprocessor, when you give a power, ground, on the first clock edge, the microprocessor gives address. You know how they will, this is clock. How they will mark address. The first address is 0 always. Because this is 16-bit. I put 0, 0, 0. Then I draw here is a very important. I draw from this middle to this middle. This is called, let's say, T address, TADD. We write like that. Then I write here, read. It will go like this. And we draw like this. This middle. We call this as a T read. We call T read the time. Then write, it goes 0 because I'm not writing anything. Write is 0. Now the data, the other guy puts the data after read. So data comes anytime. Data comes anytime. See that. This is here. From this to this. Your memory. After you give a read, he will give data. This time is called T access or T access time. T access time. That is the time the memory take you to give you the data. Now, all this clock edge, we accept the data. We accept data. Now what happened? After completing this operation, I accept data. This guy will put the memory right state address. No more address. Then I finish the operation. Now the read will go down. When after this falling edge. After address and read has fallen down, our man, who the memory, will give the data down. Now all become, this becomes 0, this becomes tri-state, this becomes tri-state. Because address is not there, or memory has removed the tri-state. Now I'll write here maybe 76. That's the data given by memory. This is data. And 8 bus, D02, D7, A02, A15. And we also write this time. This time. TCLK. And we also start giving so many other information. What is a falling time? This to this. So many information they will start giving. Okay, let's not worry. We talk about only T. What is important is clock. So if they say that now they will give you a table. That's a trick here. They will give you a table. On the table, they will mention all of them. What they will mention? TCLK and T address, T read. Only the 3 they will give. But this is given by the microprocessor manual. And there is another timing diagram for memory. There they will give you T access. Understood? This microprocessor don't know how much time memory will take. After you give a read, memory will. So this is depending on memory, and these are depending on the microprocessor based on the clock. If you reduce the clock size, the duration, then the time will change. Okay. Is it clear? That is, if you say that this timing diagram, now I say that 1, 2, 3. Now what will happen? 1, this is 1. This is 2. This is 3. 3 clocks. And the 4th clock, I will start next cycle. I'll put the next address. 0001. I will do the same operation continue. That's called one, you may call this a one machine cycle. That's why typically called one machine cycle. The one machine cycle is reading one data, that is 3 clocks. This is called T state. This time is called a T state. Do you understand this? If you have any doubt, you can ask me now. The diagram, if you have any doubt, you can ask me. Is it clear? Now you start seeing the timing diagram, and if you have any doubt, or we can also see right now. Let us see that some timing diagram. We'll share it out. I'll stop the share. I'll take some data sheets. Let us take some data sheet. Yeah, let us take a, now we are going to discuss next what is flash. Let us take a timing diagram. We'll go down. Where is it? This called? See here. Do you see that? This is called A, address line of this bus. The moment you give us this one, how much time this game will give you the, forget about this TRC, they're all given here. See here on the, this one, what do you call? Bottom or top? Here, yes. No, this is different. I think they were given the top. See, all the timings are given here. See that. Okay. How much is the address valid to next address valid? Okay. That is about TRC. That's about TRC. So the TRC is, they say how much? 70 nanosecond minimum. And unit is nanoseconds. Okay, now you go and see the diagram now. See here, one address to next address, 70 nanoseconds. That means that you should keep minimum 70 nanoseconds there. If you don't give that 70 nanoseconds, then it's gone. Now you see here, this signal, he has given a TCE. CE is chip enabled. You know, C is chip enabled. And this one is called data valid. TCE is the one from a give chip select, when the memory will give data. You go up, go and see that. See that? TCE, 70 nanoseconds. CE low to output valid. So everything timing diagrams, you're supposed to follow this. This is what we do is we verify with logic analyzer. We will check this wires and the logic analyzer will see this diagram. We will compare with this. Understand? So these are all the timing you're supposed to meet. This is what the job of a hardware engineer. But nowadays, this job has come to software because all the timings are programmable in the chip. That means that you can do anything. See that? This is what, there's nothing. See that? I told you, see here. It will go like this. Data. Then address will go like this. Then the signal will go like this, high to low or low to high. There's nothing more than that. And they will tell you the timing between each two. This is what timing diagram. Any timing diagram, they will tell you this. Write it and then they given a timing. See this. You see here, when this time no data. That's why they black out. If you can understand the timing diagram, you are the most wanted person in the industry. But the trick is that they may not expect as a fresher these things. That's the problem. You have to go and tell them that I know timing diagram. You should write on the resume. I'm good at timing diagram. See here. See, you see here what they have written. Chips block arrays. What you're supposed to give? You're supposed to give 555. Then 2 AAA. 555. You see, that's what you're supposed to give. Then what the command has to be given in the address. This is the address. This is command. If you give that, the chip will be erasing. This is called, they call chip block arrays. But where do you get this data? What address I supposed to give? You see that 2 AAA, I should write 55. 555, I suppose write AAA. For that, they will have a command here. See here, they would have given beginning itself erase operation. Where is it? Here, block erase. If you see the block erase, they'll have a commands. All the commands, chip erase command. There, you will see that all the there'll be a table will be given. The table, they will tell you all the. We'll discuss about that. I'll show you the commands also. Where is the commands? Commands. Registers. See here, these are the things they're supposed to give it. Yeah. This is actually a propagation delay. This is actually, calling it a propagation delay. They call it different names. That's the only thing. See, this is all they've given. What address, what data is to be given for you. These are tables you're supposed to follow as a software person. This is called, I'll discuss about this next. Before that, I just want to show you a diagram. This you should understand. Okay. So first of all, let us make sure that are we clear about timing diagram? I have given a small timing diagram of microprocessor. We will discuss the same thing when we discuss about in 8085. All the timings, various timings we will discuss, how much time it takes. So you can be able to calculate. Okay. Is it clear? If you have anything on timing diagram, let me know. If you have anything on timing, I just shown you here. I've drawn a timing diagram. I've shown it. I've given a data sheet from Micron. This is actually a Micron flash. See Micron company and the flash. The size is how much? 256 MB. Megabits. Sorry. This small b means megabits. Capital mean this means megabyte. Small b is megabit. Okay. So that's why I've shown here how exactly it is there on the chip. Read characteristics, how it is, how they draw the timing diagram. Normally we see this. Oh, fine. We are matching. Are we doing this? Everything fine. This is what every hardware designer should know perfectly. But very unfortunately, today it has gone to software also. All the timings can be controlled by you in the software slowly. If you don't meet the timing, then you cannot write. Am I right? If it is clear, I can go to the next one. I'll stop this. I'll finish off this and go to the next one. Okay. So let us get into the our next topic. So there's no doubt about the timing diagram. I can erase it. This is sufficient. If you learn this, then you have to read any timing diagram and verify all the timing. Then you will just take it. You take any chip you take and watch the timing diagram. If you have a doubt, ask me. That is now ball is on your court, asking me. Now, we will discuss about the next one. That's called, we discuss flash. And we discuss ROM initially. The ROM we discuss between rows, column, we have diodes. These diodes are that fixed by the manufacturer. You cannot change it. That's why it's called ROM, read-only memory. Okay. Later, they have added a fuse here. The fuse can be removed, but you cannot add it. That is called OTP, one-time programmable ROM. And then what they have did, they removed the fuse. Instead, they had a transistor. That's all we call FG MOS. Okay, floating gate metal oxide semiconductor MOSFET. That was used. The advantage is by this gap, there is a gate. By charging and discharging, I can able to make this one as a connection or no connection. Okay, that's the way we discuss all these things in the ROM discussion. And later, so it's called ROM, PROM, EPROM. Then came EEPROM. That is called electrically erasable. This is UV erasable. This is electrically erasable. But the electrically I'll be erasing only 1 byte at a time. And that will become too slow. So finally, when they got block erasable. Block electrically erasable, sorry. Block electrically erasable PROM. Am I right? This block electrically erasable PROM is the one which had so many of them. I can erase all of them. That means that I have a in every row, I have so many bits. Like that, I have so many bytes. Together, I call it as a block. I can erase a block. So if I have a memory of 1 meg, we have a memory of 1 meg, 1 megabyte. I'll say divide into so many blocks or 64K. I can erase block by block. I need not to erase 1 by 1. This is called flash. The flash is nothing but EEPROM. But what? Block erasable. That I will show you now. I'll show you now one small thing, our data sheet. In our data sheet, we can see that. If you see here, this data sheet, if you go to the first page, this size is 256 megabit. That means that the size is 256 megabit. Why they have done a megabit is you can use this flash as a 8-bit or 16-bit. But the size is 256 megabit. If you use a 8-bit, then the number of locations is 256 megabit divided by 8. How much? 32 megabyte. 32 megabyte. That means 32 locations are there. 32 mega. That means I need 2 power. How much? 32 mega. How many address lines? 2 power 25. I need. Now, if I use this as a 16-bit device, each line 16-bit, then divided by 16. In that case, I will have how much? 2 power 250 by 16 is 16 mega. This one word. One word means 16-bit. So that means that I need only 2 power 24. This is what they say here. Density. Okay. And they have something called single level and multi-level. That will this is called SLC. There's something called MLC and TLC and QLC and all. That we'll discuss later. That's actually how many layers it has. Single layer, multi-layer, and tri-layer and quad layer. Now you see here, uniform blocks. Each block is how much? 128 kilobyte. That means that if I have a memory of, let's say, let us make it say 8-bit, 1 byte. That means 32 mega. That means that 32 megabyte. So this memory is 32 megabyte. 2 power 25. And each block is 128K. Now that is totally how many blocks are there? 128K means how much? Oh, I don't show this one. Let me start this. Now you see here, I have, this is 32 megabyte and 32 mega divided by 128K. It is 32 mega is 2 power 25. 128K is 2 power 70. 2 power 8. That means that I have a block 0 to block 255. I have 255 blocks. Yeah, you are right. 256 block. Somebody has given a correct answer. Very good. That's it. So now this is another thing very important you see here. They have written how much? 1 lakh, that is 100,000 erase cycle per block. That means that you can erase this only 100,000 times. If you do more than 1 lakh time, if you erase, then that memory chip will become waste. And also, they say that the data return is how many days? 20 years. Typical, it will be more, but typical. That means that if you store today, after 20 years, if you go and read it, it may not be there. That's why they say that it's 20 years only it can retain the data. Understood? And block erase take how much time? You see that to erase one block, he take 0.2 seconds. Okay. And while programming, for every byte, it takes how many microseconds? 25 microseconds per word or per byte. So these are all the information. While I'm reading, how much time it takes? Random access, it takes out how much? 70 nanoseconds. See, there is advantages there. Block erase is there, chip erase is there. I can erase a whole chip. Now we will discuss how to do all these things. That is a trick. The trick is not about this. And there's one more pin is there. See the pin. That is called write protect, WP. That means that the chip cannot be erased. If you make this pin as low, if you pin the low, the chip will not be erased. Okay. Then you have all the options: validate protection, non-volatile protection, password protection, everything. All are there in this. And let us see the size, this one, addresses. Let's see the block diagram, chip port, signal assignment. You see here, this one. See, A0, A1, A2, A3, A4, A5, A6, A7, A8, like that. All the address lines, A17, A18, A19, 20, 21, 22, 23, 24, 25. You see what they have written. 23 is used for 256 meg. If it is a 512 meg, they use 24. If it is more than that, they use 825. Otherwise, RF is reserved for future use. Now you understand. Then it's called, there'll be one thing called byte. If you make it low, it will operate as a 8-bit mode. If you make it high, this game will operate on 16-bit mode. Then VCC. Okay. Then you have a VSS ground. Chip select. C is chip select. RFU is reserved for future use. Then you see that this is ready or busy. That means that you give a command, whether he is complete or not, it will know that. Then next one is write protect. Then it is reset. And the reset is like reset, it will reset the whole chip. Then write enable is you are going to write something. But we are going to discuss about how to write into the RAM now. How to write into the flash. Okay. That I have already told you that. You can go down. This is a chip diagram. Forget about it. Various types of chip diagram. See, this is a pin notes. They have mentioned. Learn how to read this. You can download it and read it. Otherwise, I can share it with you. This is I just downloaded. Now, see that how many blocks they have. How many size they have given it. Each block, what is the starting and ending addresses? If it is 64K block, how many blocks are there? Okay, that is what they write. Now is the very important. Okay, the bus operation, see here, read. Chip select is enabled low because it's active low. And output enable is low. And write is high. It is high. Then it is called data output read operation. Now, if it is a write operation, then the moment standby means you make C is high. It is called standby. Now output disabled. That means that you make it chip select, but read and write are not there. That means that all of them are high. C means impedance, high impedance state, tri-state. That's called they write high. We discussed in depth about in what do you call it? Our tri-state. That's why I given a lot of priority for tri-state. Everywhere you will see only tri-state. Now this is the bus operation. Now let us see that what are the commands. That's very important for us. How do I do that? See here, this is what the trick. See here, program, operation setting, any address, and DQ should be low, and DQ6 to be toggle. Then that guy understand this is what programming. Blank check. All the operations, what you're supposed to do is given here. Now, you may not agree it, but it's here like this. What is happening is in the flash. I'll make this as a big one now. Then you will understand. I'll explain to you, then go share with you. I'll explain then share with you. Sorry, 1 minute. Okay, now let us see. This flash, all the flash, they have a flash memory is here. You have address. You have a read. You have a data. Data is given by this guy, and read is given by you. You give address. This is what we think memory. But apart from that, all the flash, they have somebody called controller. Now this guy takes the address. This guy takes the write, and this guy also accept data. Read, sorry. And data. Both two people are sharing, but that guy accepts only write. You understand? There's a trick here. This guy is having a small amount of RAM. They call buffer. Now, this guy is a controller. This guy is having an interface with this guy internally. And if you give a command here, if you do anything right, this guy will not accept. You cannot write because he don't have a write here. But this guy has. The moment you give a write, this guy will accept your command and do the operation. Now you can fill the data in the buffer. Let us say the buffer is 256 bytes. Let us see the data sheet itself. Let us see the data sheet itself, then it will be clear for you. I go to the data sheet. I need to show that now and then the data sheet. Otherwise, there's no point. I need to show the data sheet. Let us stop. Let us see whether he is having a beginning itself. Somewhere she should have given. Oh, see, I see that. See, here's a buffer program, vital word, program buffer. Okay, this is called buffer. This guy is having vital word means vital into 2. That is about 1K. This is about 1K. This block. So I wanted to check how much these people are having. Okay, so this guy is having 1K. So from the microprocessor, you have a memory. And this guy will from this memory and transfer the 1K here. Then I'll give a command to him program. Then that guy will program. I tell him, hey, erase. I told you, this is what the job of controller. The controller does every thing makes easy for you. This is called in-system programming. This is called ISP, where I do not have to take the chip out. I have already told you that there is a UART. Through UART, you connect your laptop. From the laptop, if you download it, it goes to UART. Then I told you there is a boot ROM. That program, the boot ROM program will take it from the UART and put the data in the memory first. Whenever you do, it will give the memory. From the memory, it will copy to this buffer and tell this guy, the flash controller, a program. That guy will do the programming. So this much things are there inside your flash. This is not only flash is there, along with that, there is a controller for writing the data into the flash. That is the way you are downloading the software. This program is already written by the company. Suppose, let us take assuming, I have written my own program. Then, unfortunately, not unfortunately, I have a temperature sensor. And that guy is checking the temperature every 1 minute. Every 1 minute, that guy is taking temperature. I want to store the temperature. I want to store the temperature. And I have a flash. I can write it. My program will write it to the flash. This is called IAP. In application programming. That is, your application itself is writing. That is called IAP. The other one is called ISP. That is from outside. From outside, if you program, that is called ISP, in-system programming. If your software, you know one thing, to be honest, this is all very easy. You can write it to the flash. All these things are nowadays it's become very common. I've written a lot of applications like this. If somebody come to the next stage, ask me, I'll be able to help you write it to the flash. These are all the one which you should write on a resume. If you say that programmed, not flash, using C programming, then you know that the interviewer will be very happy. Programming non-flash. I'll explain next what is non-flash. What is the difference between these two. So please understand, there is a controller who accepts various commands from you. These commands are given in the sheet. I will go to the data sheet once again after this. So that means that, as I previously explained to you, that like LED controller, RTC, like that, this flash is having a controller. Once if you learn how to write the controllers, then there's nothing like it. They're all same concept. You can start. So the rule of the game is, first you learn how to C program, then you do passive programming on ESP, then controller programming, then you start writing function. You can write a function called erase. If you call the program, it will go and give a command here, it will erase the flash. Then you will give a command called write. Then that guy will write. So you have to start writing various functions. Understand? That you can do it. I know that you may be having some confusion. Okay, ask me anything. Somebody has around. MAC address. That is on Ethernet. Nothing to do with this. That is called the MAC. I don't know any MAC here. I don't know what is called, what you are saying, that boosting memory. I don't know what is boosting memory. I don't know MAC address. Sorry. MAC address I know. That is called MAC, MAC address. But I don't know. These are all a lot of that's all. That media access control is the Ethernet MAC address. But he's asking about booting the memory. That's why I don't. It's not coming into the memory. It's coming into the Ethernet MAC. I don't hear about anything on here. Okay. When we discuss Ethernet, I will tell you about the MAC address. Now, let me go to data sheet. It's a very complex one. It is not as easy one. I told you the RTC one, all those things are easy. But this one is slightly complicated one, but okay, fine. Let me explain to you. When you have a time, you can download and see the data sheets. It'll be very, very interesting for you. Like a story, learn it. Like a story, learn it. This is how many pages? Oh God. Hey, it's 81 page only. It's very small only. This is also not big. Normally data sheets will be of 400, 500, 1000 like that. This guy is having only 81 pages. It's very good. 81 page, you can just go through that. But read as a, don't try to understand. Just to read them. See, they written memory organization, memory configuration, how much they have it. Then memory map. Then they have a bus operation. I told you this. How I read, write, everything. Then you have a What are the registers it has? That's a very important. That's called, see, data. It's called data polling register. It has one register that has so many bits. Then lock register. See, the lock register, if you set this bit 1, that is called password protection enabled and non-volatile protection. Then external memory block. These are all can be done with this. This is right, like write it into any memory. The moment you write once, then you will understand everything. And the beauty is they will tell you that what address it is, what address you should write. See, they've written, see, this is what they've written. Standard command definition. Read what you should do. And erase, see that, unblock. What address you should give, what data you should give. You see here, you want to erase, program suspend, write to the buffer. I told you there is a buffer. Write to the buffer. Okay, what you should give. These are all the commands you will learn. See the chip erase. If you give AAA in the address line, and the first clock, if you give AAA, then if you give the other one AAA 55, AAA 80. See 1, 2, 3, 4. Let me see that. How do I do that? Let me just erase that. Let me show that then you will understand what this is. That's a trick. Since you have not seen it now, you're not believing it. Now, if you want, I can write and give you one. You can able to do that. If you want, I can write the program. See, now I say that char star PTR. Am I right? I say PTR is equal to 0x AAA. Then I say star PTR equal to AA. Am I right? Then I write once again PTR equal to 0x. Oh, board is not visible. How come board is not visible? 1 minute. Board is visible. It is small. Actually, it's a very mistake. Let me do one thing. I don't know how to make this. I've not yet done that. Okay, adjust. I'll do something later. So now I've written 0xAA. Then I've written 0x55. See that. See the first data I'm writing. I'm using a 8-bit mode. Okay. Then this guy says that on a first address AA, then give AA. Then the second address give 555. Then I put star PTR is equal to 0x55. I follow his pattern. See that. Then third address I write PTR is equal to 0xAA and star PTR is equal to 0x80 because he has given this 80. Understand? So if I can write it much bigger, I will write character star PTR. PTR equal to 0xAAA. This is, I see, I told you already so many times, when it comes to controller, don't think, follow the rules, follow the data sheet. See that, keep the data sheet and writing. The data sheet they have written, if it is a chip erase, you want to erase the chip, then if it is a 8-bit mode, I'm going to operate the chip as a 8-bit mode. Then they say that the address line give AA. I'm giving AAA. So the microprocessor on the address line, will give AAA. Am I right if I write this? Then they ask me to write data line. How much? AA. I put star PTR 0xAA. Understand? Now the data will become AA. And this is a write operation. This is a write operation. The read becomes 1, 0. Write becomes 1. This is a write operation. After writing this is gone now. Now they say that second write. The second time what I will do, I will change data to 555. Why? I don't know why. Because they have asked me to do that. They've asked me to do 555. I do 555. Then data should be 555. I do that. Done. Then they've asked AAA 80. I say that AAA 80. Like that, you have to write. I have to copy and paste how many times? 1, 2, 3, 4, 5, 6. This will be a function called erase. Void erase. You will call this function as a void erase. That's all. You will write the 6. There's nothing, only one time if you write it. Next time if you call the function, the chip will be erased. That's it. Then you see that the 4th clock I've written, they asked me to write AAA and the data is AAA. That is this. Don't ask me why. These are all their internal operation. You don't know. There are about hundreds of people, hundreds and thousands of people worked and designed this. Now this is 5A. Never try to understand controllers, then you're gone. What you have to understand in controller is what to write for what operation. See, block erase. You see that? I've written a block erase. It means that I should tell him what block. That is what here, block address. See here, they're given a block address. On this 8th cycle, in the case of chip erase, I write AAA and data is 10. That guy understand the chip has to be erased. But if I give here, instead of AAA, if I give that this one, 001, then if I give 30, because he said 30. Now that guy understand who? That your flash. Understand, oh, Balaji want to write block 1. He will write only 1 block. But if I give the same thing like a AAA and 10, because that is what shown here. I'm taking it. I'm not doing anything myself. There's no logic here. I am just following the this one, the other man. Like this, so many operations. If I want to write in buffer, what should I do? Okay, write to buffer. The address, data. You write it. It will go there. But this all looks to be very complex. It is very, very easy once you start doing. But to do this, you should learn how to write small function. If you know how to erase, write a function and keep it. Next time onwards, start calling the function. You have done. You have done. This is. But only thing is, you should know that what are these words A0. See, I'm sending A0. If this is 25, I'm sending 25. These commands are given by the manufacturer of the chip. Okay. This is what I told you the controller will accept and do the thing. Yeah, you put in the loop. You do the for loop. You put the for loop. Let us say that I say that I call this as a block erase. I call block erase. And this is called int block number. Okay. int block number, and here you give 0x, block number. Then you give here 30, because that is what this case is. You see here the data sheet. See that block address and 30. I've given 30, but I also gave all the five things before. This is the fifth. This is the sixth operation. This is the sixth operation. I've already given the 5 operations before that, which since I don't have a space, I didn't write. 1 to 5 I have written. I'm 6 to finish. I'm writing, but please understand, you cannot write, you cannot erase 2 blocks at a time. You can erase only 1 block. You can erase only 1 block. One, you can, if you want to write 5 blocks, you can write 5 1 blocks. You cannot write 5 blocks. Either you can erase the whole chip or 1 block. You can do only 1 operation. You cannot do all the things. But the problem is, after doing the operation, you're supposed to check the busy. That's the trick. If you don't check the busy, then, because I told you, from the beginning itself, the first chapter, see, they told you that block erase takes 0.2 seconds, typical. You don't know how much. It's a typically spot 2. It could be slightly here and there. You should check. Okay. Same way they would have given chip erase. How much time? They will not mention. They would have mentioned somewhere at the bottom, the data sheet. So everything they have a time. So what I'm trying to say is that your memory is also controller when you are programming. That's why they call this as they don't call this as a write. They call this as a programming. It's a big operation. You should erase and the block. The block is having something you cannot rewrite. See, understand one thing. In your RAM, let me I've shown everything, memory organization, bus operation, registers I've shown you. And I've shown you that commands which you have discussed already. You don't have, I can start it. I just downloaded from the this one. What do you call Micron? And we discussed about this. And this is what DC characteristics. You see that DC characteristics is different. See, they say that input load current plus or minus microampere, 1 microampere. Now output leakage current, how much? Then if you read a random read, how much is the current? Every pin they will say that how much current it will take. This is a typical and then maximum. This is what DC characteristics. DC characteristics tell you that how much is the current. And they may mention about power also. Oh, this is very important. They say that input capacitance, how many picofarad? That's why based on the rise time, the frequency. This is what another important. Supply voltage. This is called operating condition. You should give this flash 2.7 volt minimum, maximum 3.3, 3.6. The input output supply voltage is this. You can give 1.65 to 3.6. You understand? If you would like to give a VHS, high voltage, then you can program faster. That's another extra advantage here. Then what is the temperature? That is another important. Minus 42 plus 85. These are the thing. They will tell you an operating condition. And this is what absolute maximum. We cannot go beyond that. You cannot go beyond that. It's called absolute maximum. And this we have seen the timing diagram. Am I right? We have seen timing diagram. We have seen DC characteristics. We have seen AC characteristics. This is what we have seen the timing. How much time each one takes. I showed you the clock diagram. You can see the clock now. sorry, timing diagram. Try to understand. Read this data sheet. You will try to understand. Read this data sheet fully from page 1 to page end. Don't try to understanding skipping the pages. That does not work. Okay. Now what else exactly what? These are all the other one, package dimension. They will tell you that how much is each pin the gap. What is the size of the chip? See here, this is 20 mm. And this one is so much mm. The TSOP package. There are so many packages. We will discuss about all the packages from deep, PSOP, PGA, this one, BGA, all these things. What is that? See here, this is BGA. The chip bottom only ball is there. It will just go there and stick. They will give you all the dimension. See here. How much is the dimension? 0.375 mm. Okay. Then what is the distance between them? These are all the thing we are using it to do the PCB. So this is the way we read a data sheet. I've also told you today how to generally we read data sheet. If you read part numbering, this will tell you if you get a chip. If you get a chip, it will tell you that what is the micron company first. Then is a parallel NOR flash. I'll discuss later what is serial NOR. There is something called parallel NOR flash and serial NOR flash and NAND flash. Then you see W. This is a 2.7 to 3.6. Then what is the size? If it is 512 means 512. If it is 128 means 128 MB megabits. Then it's a single die or two die. Then which generation that is, and revision A or B. Then what is the configuration, x86 or x16? And here, block structure, high lock or low lock, that I have to see that. Then what is the package type? It is a BGA or what it is. Security, one-time configurable or standard default security. And special options, standard one. This is not a military one. Then operating temperature. And production status, blank. Engineer sample. You know what is this engineer sample? If you say engineer sample, if you give your, let us say that you are making, for example, let us say Samsung is making 1,000 phones. For all the 1,000 phones, it cannot program. So it gives the data to the company and the company makes the program and give it to you. That is called engineering sample. And it's a production one. So you will get production one means, oh, this quantity is a production quantity. Okay. When I make a new chip, I will give you the engineering sample for you to test it out. So this should be blank. If it is a ES, don't use it. That cannot go for production. That's why they say blank for production, ES for engineering sample. So this is the way. Everything is here. You have to read this. You have to read this general description. You have to read this to see all the features. Try to understand everything. You are an embedded guy, man. You should learn this. There were three types. One is parallel NOR. Other one is, see this, serial NOR. And third one is hey, what happened? I'm calling the same thing. Serial NOR, parallel NOR. That's correct. What am I doing now? Oh, that means I have not opened the NAND one. Let me. This is called NAND flash. Okay. NAND flash, you see that the only difference between NOR and NAND is very simple. It's a big one, not a small one. The chip do not have address lines. There is no address line. How can you have a memory without address line? That is called NAND flash. Your data is there, DQ and all, but address is not there. You don't have address line for this NAND flash. Okay. See, it has all the data lines, no address line. That's a trick of the NAND flash. We'll discuss about later, that one. I just wanted to make sure that you understand this or not. That is, how do you read the data sheet? Okay. Basically, you have to know that now. What is timing diagram? And then second one is how to read the characteristics, AC and DC characteristics. Then how do you program the NOR flash? Okay. Now I'll just give you the small idea about that. There were 3 flashes I told you. Okay. One is NOR flash. One is NAND flash. One is serial flash. Now there were 3 flashes. One is parallel. One is 2 flashes. One is NOR flash. Other one is NAND flash. In NOR flash, there are 2 types. One is called parallel. Other one is called serial. And this one is called sequential. Understand? Parallel, serial, sequential. And another beauty is this one is called parallel, serial, random. Or you can call this as a parallel random access. Access and sequential access. Or you can write this as a NOR flash random access. So all NOR flash are random access or NAND flash are sequential access. Okay. Here is a trick. I have told you that RAM. In RAM, there are 2 types, RWM. Other one is ROM. A ROM, this also we call RAM. Forget it. This is actually RWM. In RAM, and before RAM, the memory, there are 2 types. One is RAM, one is SAM. SAM is sequential access. Sequential access. Now ROM, PROM, OTP. EPROM. EPROM. Flash. Not flash. These are all coming under random access. But unfortunately, your other flash, not NAND flash, is coming under sequential. Okay. all your SD card, SSD drive, your pen drive, all of them are using only what? Your NAND flash. Nobody is using NOR flash. NOR flash is used in your microcontrollers between your microprocessor and your this one. What do you call? Microprocessor and the flash. This flash is parallel NOR flash. Parallel NOR flash. You know one thing, in your PC, you have a this one. What do you call? Microprocessor, Core i7, Core i5. That is connected to the serial NOR flash. That is SPI. That is not connected in parallel. Please understand, there were three. One is parallel NOR flash. All your microcontrollers, microprocessors connected to parallel NAND flash. But in your PCs, on mobile phones, we have a serial NOR we use. And all your SD card, SSD and pen drive, everything, this we call storage. All storage are NAND flash. All the memories are NOR flash. So this information, you keep it with you. Okay. Please have the view once again the video and try to understand. Next class, we will discuss about all this thing. What is serial? Why? How come a PC is booting with a serial NOR flash? What is a sequential access? What is the advantage of that? What is the disadvantage? How we are using SD card? Let us say that you have a microcontroller, ARM microcontroller or Arduino or anything. If you know how to write into SD card data, you have done. It's all advanced. This is all experience. If you gain it before you go out of the engineering college, you have done. You have a huge advantage. And this terminal, whatever I'm telling you now, if you talk to your interviewer, all these things, you win. You win the game. They wanted you to know all these things. Today, interviewers, they may ask you, you don't know, because if there's a competition is high, they want to choose the right person. They will try to choose they will ask you, what is the difference between NOR flash and NAND flash? Done. That time you should tell him that NOR flash is random access, NAND flash is sequential access, and also in a NOR flash there are two types: parallel NOR flash and serial NOR flash. That's it. That guy will be amazed. You are very clear, man. Why that guy is not going to select you? Is that guy is full? The interviewer. They are looking for an embedded engineer, man. They wanted to have a people. Okay, so if you have any doubt, you can ask me now. Because I've taken a very much complicated topic slowly, but no way. We have spent a lot of time. Initially, all the fundamentals. Now you should know that if you don't discuss all these things, then there's a waste of the course. But now you have to put enough time. Now you have to put the enough time. You should get into this one. Your reading data sheets and all these things. If you don't do that, then no use because of this. This will be useful only if you do the other things. Parallel NOR flash. Parallel NOR flash. all our microcontrollers are using parallel NOR flash. NOR flash. Not only normal, it's a parallel NOR flash. All our microprocessors which use microcontrollers. Only in the your mobile phones and PCs, laptops, they use the serial NOR flash. Because they don't have a space. They will try to avoid putting a small chips. I'll tell you that when you will use normal NOR flash, when you will use serial NOR flash. Any other doubts? Any other doubts? So we discussed about timing and all these things. Try to understand that. And if you go through the data sheets of the Micron or any company, then you are very good. Yeah, SSD and pen drive is NAND flash. They are called storage. All storages are all NAND flash. After discussing about flash, I will discuss about hard disk. That time I will discuss about SSD and pen drive and everything. See, today all these things started getting used into the embedded. If you know how to do the NAND flash controller, you are too good. Learn it. They're not very tough. Any C programmers, these are all nothing, the child's play. If you say that I'm not able to get these things, I can put you very clearly that you don't know C programming. You're not practiced C programming properly. For a C programmer, these are all nothing. It's a cakewalk. That's why industry wants electronic students with C programming, with embedded programming, knowledge or something little bit. They don't expect too much. But if you tell these words, I have done a NAND flash programming from scratch. You should write the word called from scratch. Then I have written a SPI I2C bus from scratch. You should write everything what you have done as a project. Neatly document it. So nicely, what you have done has to be, you should know how to document all your work. No, cache is not a flash. Cache is not ROM. Cache is a RAM. That is SRAM. Correct. No, you should write them as under the thing called skill is correct. Yeah. Under project, you can write under the project. You convert this into the project. A small project, writing this one, what do you call? Increasing the timing of this one, NAND flash writing. Then he will ask you what. See, you should drag the interviewer to your line. I know you know one thing. I told you beginning itself. As an interviewer, I will ask you everything only from resume. So you can always drag me. So you should know very clearly what you write the resume, you should know it. That's a trick. Yeah, no, you should not give a delay. You're supposed to read the this one, that there's a busy pin is there. You should read it. You should read the pin to make sure that, or a status bit. You should keep on reading to make sure that it is okay, not a delay. We don't give delays. We never use delays in any, while programming, we don't use delays generally. The problem is if you use delay now, if you use different microprocessor and microcontrollers, your program may not be work. Delays, what I showed you, is only for initial stage. Normally, delay is not a right methodology. Master C programming and get you to the embedded system programming. I given a project. Some of them already completed the calculator project. They have gone to the other one. So please complete the calculator project at the earliest. Spend your time. wisely. One day you will get a benefit, reap the benefit. Don't worry. This, whatever you are learning now, you will reap the benefit. You don't get this information, even if you work in a company, 2-3 years experience, you will not get this. These are all nobody understands this type of detail in detail about timing diagram or about all this flash, how they are programming internally, everything. Even you join a company, nobody will teach you, because why they have to create an enemy for them? If they teach you everything and the company management, they send them out, so they will not teach you. Don't think that companies, you will learn in companies. You have to read data sheets and you have to fight for it. Nobody will come and sit with you and teach you, because everybody is having a project. Okay, then I think it's time for us. Let me stop the recording.